Okay, let's talk about LED strips. So you can buy a multicolored programmable LED strip for very little money now, and even on Amazon they're still pretty cheap and they're great fun. So you can program them with the Pico, and that's exactly what we're going to do. So what are we looking at here? Well, you can see the Raspberry Pi Pico, and just for context, this shows the micro USB cable plug-in point, and these are the GPIO, so general purpose in-out pins, and they can be a little bit confusing because you've got some numbers here and you've also got the numbers here, and the ones we are interested in are the ones which have GP2, 3, 4 along the top here, because this is what we need to link our Python programming with. So if we say, which we're going to use this 7th one along from the right if we orientate the micro USB cable like this. So 7th along from the right corner, so 1, 2, 3, 4, 5, 6, 7. We are going to be using this pin, which is in programming terms going to be labeled as pin 28. Okay, now we're also going to be using this pin here and this pin here because they're our positive and negative connections. So you've got a signal wire that's going to go to this GP28, and we're also going to need sort of electrical power to light up our LEDs using this one and this one. So your LED strips come on a roll like this, and they often have connections like this on the end. Now I've already used this, so this is actually on the far end, so that arrow is something to be aware of. So you do not want to really use these connections because the signal needs to be traveling from that connection, that copper connection, this way. Okay, so you can see one here. This is my 20 LED strip that you're using for test purposes, and I've got, see the arrow is going from the signal wire this way. Okay, if you attached it on this end it wouldn't work because you're sort of swimming against the tide, if you like. So I usually cover these up so we avoid short circuits. It's only 12 volts, so it's not like a serious fire risk or anything, but you can see that black one is the ground. Okay, so just like any battery, you've got positive and negative, so there's the positive. This is the signal wire, the DIN wire, that we will send messages from the Pico to control how these LEDs light up. So this is my PDF guide titled LED Strips Intro, and if we go down to this wiring diagram, you can see the how the signal pin connects to the 7th pin along from the right, and you've got your positive and your negative that provide power to the LED strip, and you've also got the plus going to from the power pin to this rail, and the third one in is the ground pin going to the ground rail. So here you can see my LED strip is now connected. You've got the yellow signal wire going into the 7th pin of the Pico. This is GP28, and you've got the black and red wires going onto the rail. Okay, so that's the negative rail and that is the positive rail, and those rails are connected to the V bus pin and the ground pin in the corner of the Pico. So going back to my PDF guide, you've got a link here that will take you to a GitHub page where we can download the library that we need. Now a library is code that makes your coding simpler. It's something that sits in the back of your Pico, and it means you don't have to write as many lines of code because it refers to this library. So now I'm going to click on this link, and you want to click on this symbol here. You don't just want to highlight things, you need to click here, and that will automatically select all of the code in the format that we want it. So now go back to Thonny, and if you need to make a new page, you can click here, and then you can right click and paste, or Control V to paste the code in. Now we need to save it, File Save As, onto the Raspberry Pico, not onto the computer, onto the Pico, and it's important to name it neopixel.py as you see it spelled here without capitals. When I click OK, it saves it to the Pico, and that should now be saved to the Pico. This bracket, these square brackets here, tell us that we're looking at a file saved to the Pico and not the computer. And I'm just going to close this now because we don't want to accidentally edit that file. The other thing we can do is we can click on View and Files, and we can see down here this is what is saved onto the Raspberry Pico. Okay, so I can see that NeoPixel library is saved onto the Pico. I'm going to close that now because we don't need it. Okay, we're finally ready to start making these LED strips light up. So these are the libraries that we need. So we always use this one because that's what allows us to send commands to the pins that we're using on the Pico. The time library allows us to delay our code, so when it lights up it pauses for a little while and then it does something else. This is the NeoPixel library that we saved onto the Pico, and it's just telling the program that we can use that. So this grey writing here is just a little placeholder. It's like a label, doesn't do anything. It's quite useful to use these symbols to put little flags in our code. My LED strip has 20 little LEDs on it. Yours may have less or more. If you're doing a project at home, you might have hundreds. If you're doing something in Pi Club, you might have a test strip which just gives you 5 or 10 LEDs. So count them and write that number there in your code. This variable is telling the program that the signals are going to come through GP28, that one which is 7th in from the right. Now we also have a couple of color variables. As your project gets more complicated, you might have 10 different colors that you are using, but at the moment we're just using red and blank, and these are RGB values, red, green, blue values, which is why this is here as well. Now if you wanted to choose your own colors, you could easily look up what those values are. If you just search on the internet for the W3 Schools color picker, you'll get this page. So if I wanted to select a really tasteful shade of purpley pink here, I could then grab these RGB values and put them into my code. In fact, let's do that now. So if we have here pink is the name of the variable, and then equals, and then in the brackets we want to put the values that are on in this website, and we can even just copy them and paste them in, and you can do that with as many colors as you want to use, but let's keep it simple for now. Okay, blank is important because we need to be able to turn our LED strips off. So we've got red and now we've got pink, but we're going to use red and blank in the first instance. So here, now we've set our libraries and our variables up, and we know the number of pixels, and we know that the GPIO pin is 28. Now we can finally write some commands. So this fill command means all 20 will light up. We've chosen red as our color, and you always have to remember to put this or it won't actually light up. Then we've got a 2-second delay, and then it's going to turn off that color. And again, don't forget to put this, or this command won't be actioned. So let's see if it actually worked. So make sure that you do have your MicroPython Raspberry Pi option selected here, and then you click play. So we can see here it did light up, but why is it green? So why is it green? Well, to be honest with you, I'm not entirely sure. Something to do with the way the LED strips are wired internally. I think an easy fix is you just go along to line 7 here and you swap over. So instead of RGB, it says GRB. And then if you run it, it will actually light up as it should in red. So let's review some more commands that you can use in controlling these LEDs. We've done strip.fill, but as you can see in the LED walkthrough that I've got in front of me here, you can control the individual LEDs. So if we do set pixel, this is the first LED, so it starts at 0, so 0 is the first LED, and then you set the color. So this one here, you can make it so the first one is red, the second one is blue, and the third one is green. So here you can see I've deleted the first lot of commands that use strip.fill, and now we've used set_pixel. I've set the first pixel to be red. I didn't have green, so I've used the pink variable here for my second pixel. Don't forget to include strip.show or it will not action that command. So let's see how it looks. So we can develop this. Let's stick with red for now. And what you could do is, the long way of doing it would be to copy that and then paste it and paste it and paste it, and that will, we can then change these to be sequentially going up, and if we run that we should see it moving up along the strip 1 pixel at a time. So I said this was the long way of doing it because this isn't very efficient. It's repeating loads of code all the time. So let's just go back to the first 2 lines and use a for loop. Now, a for loop will allow us to repeat the code that has been indented. So you can see here that's been indented and that's been indented, so it belongs to this for loop. Okay, now this x, it starts at 0 and then the next time it loops, it automatically, you don't have to do anything, increments to 1, then it increments to 2, then it increments to 3, then it increments to 4, then it increments to 5, and when it gets to 5 it stops. It's called a count controlled loop. So we can use this variable here so that on the first loop it runs the first pixel, and the second loop it'll make the second pixel, and the third pixel will light up on the next loop, and so on and so forth. And we can keep going. It doesn't have to be 5, it could be 10, it could be the whole 20 of the pixels I've got in my strip of pixels. Okay, so you should see here that if you do this, it will make them all light up. Now I've missed an important step here. You need to put a time delay in there, otherwise it'll do it so quickly it looks like strip.fill. So let's do a half a second. and then let's run it again. Okay, did you manage to do it? Did you manage to make it light up 1 pixel at a time until it got all the way to the end? The really difficult bit was making it go back the other way. So let's look at how we could do that now. Now, the long way of doing it without a for loop would be to maybe take that. So we're outside of the for loop now. So that after it's looped all the way to the end, making them all light up, let's make them a different color. And let's start with the last pixel. Now, why is the last pixel number 19? Well, it's because the pixels start at 0. So although there are 20, 0 all the way to 19 gives you 20 pixels. Okay, so that would make the 19th pixel light up pink, and then we could make this the, and so on and so on. But this is going to take a long time. This is going to be quite an inefficient way of doing it. So I wonder if we could use a for loop instead. So let's make another for loop. Okay, so let's talk about this. So this is the first loop with a red, and it goes all the way to the end. I made it do it a bit faster because I was bored of watching it go so slowly. And then I've got another for loop that makes it come back the other way, a different color this time. And to set the, it's called the index of the pixel, which individual LED are we going to make light up? Well, I've got this new variable called y. So remember, x increments from 0 all the way up to 20. So on the first loop, x is 0. Okay, so y is going to be 19 minus 0. So y is 19. So that means the last pixel will be made pink. Okay, then on the next loop, this is going to increment, go up by 1. So x is 1. So y is going to be 19 minus 1. So that means that basically 18 is going to go on here. So you get the idea. On each loop then it'll be 17, 16, 15, 14, 13, 12, 11 and so on and so forth. So you will then hopefully have it zoom forward and make all the pixels red one after the other, and then zoom back the other way and make all the pixels pink or whatever color you choose to do. Okay, one final thing that is worth talking about is this out of range error that you can get. So I've made a deliberate mistake here. So y on the first loop will be 25 minus x. X is 0, so it's looking for a pixel, a LED that has an index of 25. Now we've already said that the index of our 20 pixel LED strip is going to be from 0 to 19. So the fact that it's looking for 25 here is out of range. It's not within the range of pixels that exist that we defined up here. So if you get an error like this, it's probably because you've made a mistake with the indexing of your individual pixels. Okay, so there's loads of other things you can do. Have a little look at the PDF guide for other ideas. You can make them fade, you can change the brightness, have fun with it. Okay, so now you know how to control individual LEDs and whole strips of LEDs, and you've managed to make them fade and zoom. You can now move on to the next step, which is using buttons, momentary buttons, to send an input signal into the Pico. So I won't go into detail in this in the video, but have a look for the guide, buttons and LEDs, and it will tell you how to wire up a button and then send in input signals and control how the LED responds. And that basically is all you need to create a nice lighting setup in your house at home.